Hi everyone, my name is Aisha and I'm here with my friend Kia.
Hi, today we're going to show you guys how to do a couple of mathematical problems related to binomial and geometrical distribution.
Okay, now Kia will explain her problem on a binomial distribution. Take it away, Kia.
Alright, the first problem we would like to discuss is about binomial distribution. Previous springs have shown that when sunflower seeds have been planted for at least 4 months, 80% of it will germinate and bloom. It is given that one seed produces 2 flowers if the seed germinates. A florist planted 12 sunflower seeds 5 months before spring begins and waits to see how many will bloom in spring. He will then sell all of the flowers that bloom. A. Find the expected numbers of seeds that will germinate and bloom. B. Use the suitable distribution model to find the probability that the florist will sell less than 16 flowers. Later, the florist planted sunflowers in 10 gardens with 12 seeds in each garden. C. Calculate the probability that there are at least 9 gardens in which at least 8 seeds germinate and bloom into 2 flowers each. Before finding the expected number of seeds that will germinate and bloom, it is better if we list all of the information given from the previous slide. The first one is that 80% of the seeds will germinate. So this means that the probability of the seeds germinating by spring, which is the probability of success, is 0.8. And Q is the complement probability of the success, which represents the 1 minus P in this formula, and that is 0.2. The seeds that germinate will produce 2 flowers each, and the florist planted 12 sunflower seeds, so the n is equal to 12, which is the number of trials in this case. So we can just substitute the numbers into the formula of the expected number. The expected number is basically the same as mean, and we can find it by multiplying the number of trials, which in this case is 12, with the probability of success, which is 0.8. So the expected number for this case is 9.6. Next, we want to find the probability that the florist will be able to sell less than 16 flowers. But what we know is the probability of the seed germinating by spring. Then, how do we find the answer? Well, it is also given that if a seed germinates, it will produce 2 flowers. And since the question asked for less than 16 flowers, we can find x, the number of success, by dividing 16 with 2. This equals to 8 seeds. However, what we want to find is the probability of less than 8 seeds germinating. N is the number of trials, which is 12. Since 8 is closer to 12, it is more efficient if we calculate the probability for x more than or equal to 8. Then find the complementary probability of it to get the answer. To do this, we first need to substitute each probability to the binomial distribution formula. For example, finding the probability of x equals to 8 means 12 combination 8 times 0.8, which is the probability of successful, to the power of number of success, which is 8, then times 0.2, which is the probability of unsuccessful, and then to the power of 4, which is the number of unsuccessful. This equals to 0.1328755. Then we can follow this pattern up to x equals to 12. What we have so far are the probabilities of x more than or equal to 8, and x less than 8 is the complementary probability of the total of what we have found. So the probability that x less than 8 is 1 minus the probability of what we have found. After we minus it, we can find that the probability that the florist will be able to sell less than 16 flowers is 0.0723. Lastly, we want to find the probability that there are at least 9 gardens in which 8 seeds germinate and bloom into 2 flowers each. New information that we know is that the probability of less than 8 flowers germinating is 0.0723, and that there are 10 gardens with 12 seeds planted. What we want to find is at least there are 9 gardens in which at least 8 seeds germinate and bloom into 2 flowers each. We actually have calculated the probability of at least 8 seeds germinating in the previous slide when we added the probability of x equals to 8 to x equals to 12. But we can also calculate it by finding the complement probability of x less than 8. So 1 minus 0.0723 equals to 0.9277. This way we can write a new distribution which is binomial 10, 0.9277. Since we know that the new n number of gardens is 10, y, the number of gardens that has at least 8 seeds germinate, is then 9 and 10. Then we can substitute these values into the formula. When the y is equal to 9, we find its probability by multiplying 10 combination 9 times the probability of more than 8 seeds germinating, which is 0.9277 to the power of 9 times 0.0723, which is the probability of less than 8 seeds germinating, to the power of 1. Then we add this probability with probability of y equals to 10, which also follows the same pattern, and for y equals to 9, the probability is 0.36799648, while for y equals to 10, the probability is 0.47211452. When added, this equals to 0.84, which is the probability that at least 9 gardens have at least 8 seeds germinating and blooming into 2 flowers each. Next, my friend Aisha will explain how to solve a geometrical distribution problem.
All right, so here's question number 2.
Grizz begins every day by listening to music on Spotify. He will only do his morning routine when he can sing along to 5 songs, one from each of his favorite artists: Kehlani, Billie Eilish, NCT127, Lauren Haregi, and Omar Apollo in that order. Out of 100 songs in his mixed playlist, only 5 are Lauren's, 25 are Kehlani's, 10 are Omar's, 20 are Billie's, and 15 are NCT127's. To start, the shuffle button is pressed and a random song is selected from there. If the chosen song isn't sung by the singer Grizz once, he will press the shuffle button again and another randomly selected song will play. During good days, he gets to listen to all of his preferred artists back to back, without any interruption. However, on a bad day, Grizz must skip 4 songs just to start his routine. Worse, he must then shuffle through his playlist twice to get each first song by Lauren Haregi and Omar Apollo. The question is, find the probability that A. Grizz has a good day, and B. Grizz has a bad day. The first thing that we're going to do is highlight the important phrases. It is stated that Grizz will only want to listen to 5 songs, one song from each of his favorite artists in that particular order. This means that first he wants to listen to a Kehlani song, second he wants to listen to a Billie Eilish song, third he wants to listen to an NCT127 song, fourth he wants to listen to a Lauren Haregi song, and fifth he wants to listen to an Omar Apollo song. Then the problem says that Grizz will press the shuffle button where a random song is selected, and when the song isn't sung by the singer Grizz wants, he will press the shuffle button again and another randomly selected song will play. Now we're going to highlight the second main idea. Here it says that Grizz's playlist consists of 100 songs, and we're given the number of songs from all of his favorite artists in that playlist. From the available information, we can calculate the probability of successfully getting a song by each one of them. Let's start by finding the probability of success in getting a Kehlani song, denoted by a lowercase p sub k, which is equal to 25 since there are 25 Kehlani songs in that playlist, divided by the total number of songs, which is 100, thus arriving at 0.25. We'll then follow the same pattern to find the rest. The probability of successfully getting a song by Billie, or lowercase p sub b, is equal to 20 over 100, or 0.20. The probability of successfully getting a song from NCD127 or lowercase p sub n is equal to 15 over 100 or 0.15. The probability of successfully getting a song from lower n or lowercase p sub l is equal to 5 over 100 or 0.05. And lastly, the probability of successfully getting a song by Omar or lowercase p sub o is equal to 10 over 100 or 0.10. Now we're going to highlight our third main idea. It is stated that during good days, Gris can listen to all of his preferred artists back to back without any interruption. While on bad days, he must skip 4 songs just to start, and then he must shuffle twice to get each first song by Lauren Reggie and Omar Apollo. Now let's solve problem A. According to the key phrases we highlighted earlier, Chris will be able to listen to all of his favorite musicians in the sequence he wants without needing to press the shuffle button at all. Therefore, on a good day, Chris gets a Kehlani song on his first attempt. After that, he directly gets a Billie Eilish song, followed by an NCT127 song, then a Lauren Reggie song, and finally an Omar Apollo song. Since Chris successfully gets a song from each of his preferred artists in a single try, then all the x is equal to 1. This means that it's just p sub k times p sub b times p sub n times p sub l times p sub o. Next, we just substitute the previously calculated values into their respective notations. We plug it into the calculator and we finally get an answer of 3.75 times 10 to the power of minus 5. Moving on to problem B. Here we also need to keep the key phrases in mind. On a bad day, Riz is said to successfully get a song from Kehlani after he fails his first 4 tries. Following this, he doesn't encounter any problem in getting a Billie Eilish and NCT127 song. However, later, Riz fails twice before getting a song by Lauren Reggie, and then another twice before getting a song by Omar Apollo. In total, he tries 13 times to finish his routine. Before continuing, we have to calculate the probability that Chris fails in getting a Kehlani song, denoted by a lowercase q sub k. This is simply the complement of its successful probability. Thus, we just need to subtract 1 with p sub k, which is 0.25, and we'll arrive at 0.75. We need to also find the probability that he fails in getting a Lauren Reggie and Omar Apollo song by following the same method. After finding the complement of the respective successful probabilities, we will get a q sub L of 0.95 and a q sub O of 0.90. Since Gris successfully gets his first Kehlani song on his 5th attempt, the x for that probability is 5. Similarly, because he then gets his first Lauren Reggie and Omar Apollo song on his 3rd try each, the x for those probabilities is 3. Therefore, we multiply the probability of getting a song by Kehlani, where x is 5, which is q sub k to the power of 4 times p sub k. We multiply that with the probability of getting a Billie Eilish song where x equals to 1, which is just p sub b. Multiply that with the probability of getting an NCT127 song where x is 1, which is just p sub n, times the probability of getting a Lauren Reggie song where x equals to 3, which is q sub l to the power of 2 times p sub l. And lastly, we multiply that with the probability of getting an Omar Apollo song where x is equal to 3, which is q sub o to the power of 2 times p sub o. Then we substitute the values from before into all the notations. We plug into the calculator and we'll get an answer of 8.6737 82959 times 10 to the power of minus 6, or approximately 8.67 times 10 to the power of minus 6.
That's all from us. Thank you for watching.
Bye-bye.
Bye.